When you hear the term dynasty, you might think of the Rothschilds, who influence global banking and finance, or you may think of the Murdochs, who influence global news and media. You might have seen the movie called House of Gucci, about the family that started the brand Gucci, or the movie Godfather, inspired by the mafia families, but you would probably not be thinking about mathematics. Well, maybe you should. There exists a family that, far away from public view, has had more influence on mathematics than any other. They have made contributions touching a vast array of fields that you rely upon today in daily life, and won some of the highest honors in mathematics. The legacy of mathematical brilliance spans 4 generations, originating with Emil Artin, a towering figure in 20th century algebra whose students were pivotal in establishing modern number theory. His wife, Natasha Artin, was also a mathematician. Their son, Michael Artin, achieved distinction as a leader in algebraic geometry, winning the prestigious Wolf Prize and the National Medal of Science. Their son-in-law, John Tate, was a number theorist whose fundamental contributions are recognized through the numerous mathematical concepts that bear his name. Today, Dustin Clausen, the great-grandson of Emil, is collaborating with Peter Schulze to spearhead a groundbreaking new framework called Condensed mathematics. They seek to achieve a seamless unification of algebra and topology, 2 fields that were previously considered distinct. This is the story of how one man from Vienna started a lineage of legends that would shape human logic across continents for 100 years. Emil Artin was born in Vienna, back when it was part of the Austro-Hungarian Empire, in 1898. His early life was full of music and smart conversation. His mom was an opera singer, and that musical atmosphere really shaped him. Even as a kid, Artin absolutely loved music, something his friends later said he was as dedicated to as he was to math. He got good at several instruments, like the flute, harpsichord, and clavichord. As a schoolboy in Reichenberg, he did not show any obvious early genius for the subject. He later recounted that until about age 16, mathematics meant no more to him than any other subject, and he actually preferred chemistry for a period of time. The First World War interrupted his early university studies. After completing just 1 semester at the University of Vienna in 1916, he was drafted into the Austrian army. When the war ended, he resumed his studies. By January 1919, he enrolled at the University of Leipzig, where he studied under the mathematician Gustav Herglotz. His exceptional aptitude quickly became evident. By the young age of 23, he had earned his doctorate in 1921. His doctoral thesis, which applied the theory of quadratic number fields to fields of rational functions, foreshadowed his remarkable ability to connect diverse intellectual areas. His postdoctoral years saw his reputation rise rapidly across the European mathematics community. From 1921 to 1922, he stayed at Göttingen, then the world's mecca of mathematics. In 1923, he joined the faculty of the University of Hamburg. By all accounts, he was brilliant in conversation and possessed a playful, intuitive teaching style. He believed deeply that mathematics is an art, and that a teacher must convey its structural beauty to the audience. His research shaped 2 major areas, group theory and number theory. He was a master of the mathematics of symmetry, known as group theory. A group is a set of allowed moves you can perform without changing the essential structure of an object. Think of the twists of a Rubik's Cube that leave the overall shape intact. He helped modernize this theory, focusing on symmetry as a kind of universal language across the field. A cool example is his stuff on braid groups. These groups are basically mathematical models for all the different ways you can braid and unbraid rope strands. His 1925 paper laying out the braid theory sparked a completely new area of study. Number theory often concerns prime numbers, the indivisible atoms of arithmetic, and how they combine to form all other integers. He contributed to understanding hidden structures within these numbers. One of his most famous achievements is the Artin reciprocity law. This law acts as a grand translation dictionary between two separate worlds. His wife, Natasha Artin Brunswick, was also a mathematician by training, but chose to pursue photography instead. Born in 1909 in St. Petersburg to a Russian Jewish father and an aristocratic mother, her early childhood was disrupted by the Russian Revolution. Her father was an economist who fled to Georgia when the Bolsheviks took power. She, her mother, and her sister followed in 1920, essentially refugees from the revolution. As the Red Army moved into the Caucasus, the family migrated again, eventually settling in Hamburg by 1924. In Hamburg, she blossomed academically and artistically. She enrolled at the University of Hamburg, where one of her professors was the young Emil Artin. She initially had dreams of studying architecture at the famous Bauhaus school, but family finances made that impossible. Instead, she chose mathematics. Hamburg in the late 1920s was an exciting place for a keen mind. She took courses in art history from luminaries of the era. She married Emil in August 1929. They had their first child, Karen, in 1933, and their second child, Michael, in 1934. During these years, she shifted her passion to photography. Emil gifted her a high-quality Leica camera as a wedding present, knowing how much the art form meant to her. Roaming the streets of Hamburg, she captured striking images of the city. By the early 1930s, Emil was a towering young professor in Hamburg. But political storms were gathering rapidly. The rise of the Nazi regime created an atmosphere of fear and moral danger, especially for academics of Jewish heritage and their families. The family became vulnerable under Nazi racial laws because of Natasha's Jewish descent. Although Emil himself was not Jewish, his wife was considered a first-degree mixed-race individual under their strict legal codes. This put him in an increasingly precarious position despite his academic stature. At first, there were attempts to cope within the system. The university did not want to lose him. But in 1937, Nazi laws extended to forbid anyone with a Jewish spouse from holding a civil service post, which directly included university professors. He was forced into early retirement on July 15, 1937. For the family, this was the breaking point. They faced a harrowing decision to stay, adapt, or flee. Emil was a man of principle. With the Nazi grip tightening, he saw no alternative but to leave Germany. On October 21, 1937, they were set to board an ocean liner at Bremerhaven when little Karen woke up with a high fever. The parents faced a dreadful dilemma. If officials noticed the illness, they might prevent the family from leaving under strict medical quarantine rules. Terrified this was their only window of escape, they risked it. They bundled Karen up, attempting to hide any sign of sickness. They slipped through immigration and customs without detection. A week later, they landed in Hoboken, New Jersey. Landing in America, Emil had to rebuild his professional life from scratch. A temporary position was arranged at the University of Notre Dame in Indiana. He taught there for the academic year spanning 1937 to 1938. By 1938, he secured a more permanent post at Indiana University in Bloomington, a college town where he would stay for 8 productive years. During 1938, the couple welcomed a third child, a son named Tom. Embracing the new world did not mean abandoning the old culture. The household remained a pocket of European tradition on the American prairie. Emil insisted that only German be spoken in the house, determined that his children would not lose their mother tongue. Even Tom, born on American soil, first learned to speak German at home. Emil continued a tradition of reading German literature aloud to the family. In 1946, a new chapter opened. Princeton University invited him to join its mathematics faculty. Princeton, in the late 1940s, was arguably the top department in the world, buoyed by an influx of European talent. He moved his family to New Jersey. He mentored brilliant graduate students, including John Tate, who arrived in 1948. He ran seminars and collaborated with colleagues, transplanting his European abstract style to American soil. Natasha and Emil divorced in 1958 while still in America. The immense pressures of emigration and diverging paths took a toll on their marriage. Emil returned to Hamburg alone, but soon found companionship with another mathematician, Hell Braun, who provided personal happiness in his final chapter. He passed away on December 20th, 1962, at the age of 64. But his legacy was just getting started. Emil Artin was born in 1934 in Hamburg. He was the second child of Emil and Natasha, and only 3 years old when his family fled Nazi Germany. Growing up as the son of a legendary mind carried a psychological mix of privilege and pressure. The home was immensely enriching, filled always with music and a love of learning. Emil taught Michael many things, from naming wild flowers to examining pond water under a microscope. Remarkably, Emil did not push his children to follow in his professional footsteps. He deliberately steered young Michael toward chemistry as a hobby. He bought Michael a chemistry set and spent hours doing experiments with him. There was no expectation that Michael would become a mathematician. The family moved to Princeton when Michael was 12. He attended Princeton High School and then entered Princeton University for his undergraduate studies. He entered college completely undecided on his major. He tried physics, but found the optics lab highly frustrating because he simply could not see the required visual results. He started in chemistry, but grew discouraged after breaking too many glass beakers. He drifted toward mathematics almost by practical reasoning, figuring it was at the theoretical end of the science spectrum and would be easier to switch out of later. He laughed at himself for that line of thinking in later interviews. By the time he went to Harvard for graduate school in 1956, he had found his true calling in algebraic geometry. Being Emil Artin's son could have been intimidating. However, Michael managed to honor his father while stepping completely out of his shadow. By the early 1960s, he completed his doctorate and began an academic career at the Massachusetts Institute of Technology, or MIT. Algebraic geometry is the study of shapes by translating them into algebra. Imagine drawing a simple curve on graph paper and then writing down an equation for that curve. Algebraic geometry is the high-powered version of that idea, dealing with solutions to polynomial equations in many variables. Michael made massive contributions that shaped the modern landscape of this field. One of his major works was the development of Étale cohomology. This is a mathematical tool for counting holes in shapes you cannot directly see. In topology, the study of geometric shapes, cohomology is a way to measure the number of multidimensional holes in a space. Étale cohomology is a clever adaptation of this idea applied to solutions of equations defined over abstract number systems. You cannot literally draw these shapes, but Michael developed ways to probe their properties. He also proved the Artin approximation theorem in 1969. It basically goes like this. Suppose you have a system of polynomial equations that you cannot solve exactly, but you can solve approximately to any desired precision. His theorem essentially proves that you can find a true solution that approximates those formal solutions arbitrarily well. Later, he explored non-commutative algebraic geometry. Normally in geometry, coordinates commute, meaning moving in the x direction and then the y direction gives the exact same result as moving in the y direction and then the x direction. Michael explored what geometry would mean if you allowed coordinates that do not commute. He developed theories of geometric objects defined by non-commutative rings, opening up a whole new field with deep connections to quantum mechanics. He's racked up a ton of prestigious awards throughout his career. In 2002, he got the Steele Prize for Lifetime Achievement from the American Mathematical Society. In 2005, Harvard honored him with Centennial Medal, basically celebrating him as a key architect of the modern approach to algebraic geometry. In 2013, he won both the Wolf Prize in Mathematics and the National Medal of Science from the U.S. President. Unlike his father, who moved across continents, Michael built a home at the Massachusetts Institute of Technology, teaching there continuously for decades. While Michael carries forward the mathematical legacy of his Emil, Michael's older sister Karen carried forward their parents' love for the arts. Karen Artin played the cello and piano. She absorbed the German literature her father read aloud at the dinner table. She grew up knowing that her very existence and her childhood fever on the docks of Bremerhaven was part of why her parents made the difficult choices they did to leave their home. She experienced a truly transatlantic education, starting school in Indiana and continuing in Princeton. Entering her teenage years in an Ivy League town, she found herself in a heady environment full of intellectual giants. She worked diligently to preserve and curate her father's writings. Decades later, she and her brother Tom published Emil's travel diary from a youthful hiking trip to Iceland in 1925. Tom edited the book, and Corinne translated it from German to English. In 1956, Karen married John Tate. John had been her father's graduate student at Princeton. They settled in Cambridge, Massachusetts, where John became a professor at Harvard. They had 3 daughters named Jennifer, Valerie, and Amanda. John was famously absorbed in mathematics, often thinking about problems day and night. Having grown up with Emil, Karen was uniquely prepared to understand this intellectual single-mindedness. She ran the home front with immense patience, enabling John to wander freely in the clouds of research. Their home became a vibrant social center for the Harvard mathematicians in the 1960s and 70s. John hosted legendary seminars at his house, with Karen facilitating the gatherings and making everyone feel welcome. Karen actively kept the family's scholarly heritage alive. She preserved letters, photographs, and documents that remain incredibly useful to historians of mathematics. John Torrance Tate Jr. was born in 1925 in Minneapolis, Minnesota. Mathematics lurked heavily in his background, as his father was a physics professor at the University of Minnesota and his mother was a high school English teacher. Growing up in the Midwest, he was surrounded by academia. However, he was not a child prodigy who knew his destiny from birth. When he entered Harvard in 1942, he read biographies of legendary mathematicians and heavily doubted he was in their league. He started out studying physics instead. His college years were interrupted by the Second World War. He served in the United States Navy from 1944 to 1945, learning meteorology and conducting mine-sweeping research on shore. After the war, he returned to Harvard and completed his degree in 1946. He enrolled at Princeton in the fall of 1946 for graduate studies in physics. A chance encounter in the hallways of the mathematics building changed his life forever. He bumped into Emil Artin and got into a conversation about number theory. Emil's charisma and the pure beauty of the mathematical problems he described lit a fire in John's mind. He soon switched departments to study mathematics under Emil's guidance, a decision he later called silly to have even hesitated over. He wrote his doctoral thesis in 1950. Known simply as Tate's thesis, it became one of the most famous documents in modern mathematics. To understand it, one must recall Fourier analysis, the physical process of breaking a complicated signal, like a sound wave, into simple sine and cosine waves. This allows engineers to turn something complicated into simpler building blocks. John took the spirit of Fourier analysis and forced it into number theory. Number theorists study mathematical barcodes that encode properties of numbers. These are known as L functions. John completely overhauled the study of these functions. After completing his doctorate, he joined the faculty at Harvard in 1954, where he spent 36 years of his career. He was known for his extreme modesty. He demanded perfection of his own writings and would circulate informal notes for years, improving them constantly instead of rushing to publish. He published less than he discovered, but whatever he did publish was crystal clear without any loose ends. He invented a toolkit that mathematicians came to rely on daily. So many mathematical objects bear his name. The Tate module arises when looking at geometric objects called elliptic curves. He co-defined the Tate-Shafarevich group. This group measures the failure of equations to have global solutions when local solutions exist. He developed Tate cohomology, extending a classical notion in a symmetric way to measure mathematical wholes. Across all his work, he constantly invented bridges between different areas of thought. In 2010, at the age of 85, he was awarded the Abel Prize, often considered the equivalent of a Nobel for mathematics. The Norwegian Academy lauded his vast and lasting impact on the theory of numbers. His marriage to Karen ended in divorce after about 3 decades. John later remarried, finding peace in his later years with Carol McPherson. He passed away in October 2019 at the age of 94. Colleagues remembered him as a North Star for his field and a mentor who retained a childlike wonder for the numbers he studied. He was a gentle, modest, and deeply thoughtful ambassador for human logic. Dustin Clausen was born in 1987. He is the great-grandson of Emil Artin and the grandson of John Tate. He was raised by his mother Valerie Tate and his father, living his early years in the United States. Growing up near mathematical mythology could have been paralyzing. He realized during high school that the name Tate he encountered in mathematical texts was his own grandfather. Yet mathematics was never forced on him. It was simply one interest among many. He attended Harvard University, winning top undergraduate prizes for his work. He then pursued his doctorate at the Massachusetts Institute of Technology, completing his thesis in 2013. He openly stated that he had to actively strive for his own confidence and perspective. He did not simply inherit his grandfather's insight. This required immense effort. Following the completion of his doctorate, he dedicated 5 years to postdoctoral research at the University of Copenhagen. During this time, he met and married Ida Emily Hansen, a Danish woman, and they went on to have 2 children. It was also in Copenhagen that he established a connection with his future collaborator, Peter Schulze. Peter Schulze is a German mathematician born the same year as Dustin. Peter won the Fields Medal in 2018 at the age of 30. He is considered a superstar in mathematical circles. Together, they have developed condensed mathematics. This is a brand new foundation for doing algebra when the objects you are studying carry a topology, meaning a notion of closeness or continuity. It is a bold attempt to reconcile two massive areas of math: algebra, which deals with equations, discrete, rigid structures, and topology, which deals with continuous limits and flowing geometric shapes. When you mix these two worlds, the mathematics often breaks completely. When you try to perform algebraic constructions on continuous spaces, you get pathological results. Information leaks out. The structures do not mesh. For decades, mathematicians struggled to do pure algebra when their objects had continuous topology. Dustin and Peter solved this by replacing traditional topological spaces with condensed sets. Instead of looking at a continuous space directly, you look at how that space interacts with all finite, discrete approximations of itself. This new language is rapidly being adopted across the community. It provides a unified theory that covers various complex spaces under one roof, allowing mathematicians to perform homological algebra on them conveniently. It unites the rigid precision of algebra with the flowing continuity of analysis. In 2023, at the age of 36, Dustin was appointed as a permanent professor at IHES in France. It is an extremely prestigious position. The Artin-Tate Clausen family has been builders of bridges in mathematics. They have consistently created frameworks that connect disparate areas, enabling others to traverse new territory. Emil Artin built bridges between field theory and group theory. John Tate connected algebra to analysis and local properties to global phenomena. Michael Artin shaped the foundations of modern geometry, creating a language that is now standard across the globe. Dustin Clausen continues this exact tradition by bridging the continuous world of topology with the discrete world of algebra. Their influence on mathematics is hard to comprehend. John Tate advised 41 doctoral students over his lifetime and now has over 650 mathematical descendants. The family name has become a collection of nouns and adjectives in the mathematical vocabulary.